Good morning, dear students. In the previous class, we had a discussion over the Boyles Law and Charles Law. These two are the gas laws. Uh, what we told in the last class, the different scientists were worked on the gases and found a different behavior of the gases on the basis of the measurable properties like temperature, pressure, volume, and amount of a gas. uh, in the journey of the study of the gases, the Charles and Gay-Lussac. So both scientists worked on the gases and they found when the volume kept constant, how temperature and pressure is related, and when volume kept constant, pressure and volume on temperature relation, and volume kept constant, how pressure and temperature related, pressure constant and how volume temperature related. So all these cases were identified by Charles and Gay-Lussac. Just I recall what is the statement of Charles Law. Charles Law states that at a constant pressure, the volume of a gas is varies in directly with the temperature. When temperature is rises, volume is increases. When temperature is decreases, volume is decreases. So the relation is called VT relation. So here it is relation between pressure versus volume. Here volume versus temperature. Next is Gay-Lussac law. The third one is Gay-Lussac law. What it states that, and what is the relation we observed in these cases. Okay, so ಹಿಂದಿನ ತರಗತಿಗಳಲ್ಲಿ ನಾವು ಎರಡು ಲಾಸ್ ಅನ್ನು ಸ್ಟಡಿ ಮಾಡಿದ್ದೇವಲ್ಲ. ಸೊ ಬಾಯ್ಸ್ ಲಾ ಅಂಡ್ ಚಾರ್ಲ್ಸ್ ಲಾ. Boyles law states or give the relation between pressure and volume, and they are inversely proportional. Charles law give the relation between volume and temperature. Here the last one, Gay-Lussac law, it gives a relation between pressure and temperature. Okay, in this case during the experiment of a hot air balloon, what we discussed in the previous class, same thing. Hot air balloon experiment. During the hot air balloon experiment, Gay-Lussac kept volume kept a constant. ಓಕೆ, ಸೊ ಏನು ಮಾಡ್ತಾನೆ ಅಲ್ಲಿ ವಾಲ್ಯೂಮನ್ನು ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗಿ ಇಟ್ಕೊಳ್ತಾನೆ. ವಾಲ್ಯೂಮನ್ನು ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗಿ ಇಟ್ಕೊಂಡಾಗ ಹೌ ಟೆಂಪರೇಚರ್ ಆ್ಯಂಡ್ ಪ್ರೆಷರ್ಸ್ ದೇ ಆರ್ ರಿಲೇಟೆಡ್. ಓಕೆ, ಐ ವುಡ್ ಲೈಕ್ ಟು ಟೆಲ್ ಒನ್ incident for the example. It is an example for Gay-Lussac law. Suppose you are build a full air to your motorcycle or vehicle during the summer season. ಸೊ ಒಂದು ಬೇಸಿಗೆಗಾಲದಲ್ಲಿ ಕಂಪ್ಲೀಟ್ ಆಗಿ ನೀವು ಏರನ್ನು ಫುಲ್ಲಾಗಿ ಫಿಲಪ್ ಮಾಡ್ತೀರಿ ಟೈರಿಗೆ. ಸೊ ಟೈರ್ ತುಂಬಿ ವೆಹಿಕಲನ್ನು ಓಡಿಸ್ತೀವಿ. ಓಕೆ, ಸೊ ಏನಾಗ್ಬೋದು, ಬಿಕಾಸ್ ಆಫ್ ದ ಟೆಂಪರೇಚರ್, ಅಟ್ಮಾಸ್ಫಿಯರಿಕ್ ಟೆಂಪರೇಚರ್ ಆ್ಯಂಡ್ ದ ಪ್ರೆಷರ್ ಇನ್ಸೈಡ್ ದ ಟೈರ್. ಸೊ ಟೆಂಪ್ರೇಚರ್ ರೈಸ್ ಆಗ್ತಾ ಹೋದಾಗೆ ಬೇಸಿಗೆಗಾಲ ಆಗಿರೋದ್ರಿಂದ ಫ್ರಿಕ್ಷನ್ ಜೊತೆಗೆ ಅಟ್ಮಾಸ್ಫಿಯರ್ ಟೆಂಪ್ರೇಚರ್ ಕೂಡ ಇದೆ. ಸೊ ಇದು ಎರಡರ ರೀಸನ್ನಿಂದ ಏನಾಗಿದೆ, ವಾಲ್ಯೂಮ್ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತಾ ಹೋಗ್ತದೆ. ವಾಲ್ಯೂಮ್ ಇನ್ಕ್ರೀಸ್ ಆಗಲಿಕ್ಕೆ ಟೈರಿನ ವಾಲ್ಯೂಮ್ ಎಷ್ಟು ವಾಲ್ಯೂಮ್ ಇನ್ಕ್ರೀಸ್ ಆಗಬೇಕು ಅಷ್ಟು ಆಗಿದೆ. ವಾಲ್ಯೂಮ್ ನಾವು ಬಿಕಮ್ ಕಾನ್ಸ್ಟೆಂಟ್. ಈಗೇನಾಯಿತು, ವಾಲ್ಯೂಮ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಆಯಿತು, ಟೆಂಪ್ರೇಚರ್ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತಾ ಇದೆ. ಸೊ ಜೊತೆಗೆ ಏನಾಗ್ತಾ ಇದೆ, ಒಳಗಡೆಗೆ ಪ್ರೆಷರ್ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತಾ ಇದೆ. ಸೊ ಬಿಕಾಸ್ ಆಫ್ ದ್ಯಾಟ್ ರೀಸನ್ ಟೈರ್ ಬಸ್ಟ್. ಸೊ ಟೈರ್ ಒಡೆದೋಗ್ತದೆ ಅಲ್ವಾ. ಸೊ ಅಲ್ಲೇನು ಅಬ್ಸರ್ವ್ ಮಾಡ್ತೀವಿ ನಾವು, ಟೆಂಪ್ರೇಚರ್ ಇನ್ಕ್ರೀಸ್ ಮಾಡಿದರೆ ಪ್ರೆಷರ್ ಕೂಡ ಇನ್ಕ್ರೀಸ್ ಆಗಿದೆ. ವೆನ್ ವಾಲ್ಯೂಮ್ ಕೆಪ್ಟ್ ಎ ಕಾನ್ಸ್ಟೆಂಟ್ ಆ್ಯಂಡ್ ಅಮೌಂಟ್ ಆಫ್ ಎ ಗ್ಯಾಸ್ ಇಸ್ ಆಲ್ಸೋ ಫಿಕ್ಸ್ಡ್ ಅಲ್ವಾ. ಸೊ ಒಳಗಡೆ ಟೈರ್ ಒಳಗಡೆ ಗ್ಯಾಸನ್ನು ಹೆಚ್ಚು ಮಾಡಿಲ್ಲ, ಅಥವಾ ಕಡಿಮೆ ಮಾಡಿಲ್ಲ, ಸೊ ಅದು ಫಿಕ್ಸ್ ಆಗಿದೆ, ಕಾನ್ಸ್ಟೆಂಟ್ ಇದೆ. ಸೊ ಡ್ಯೂರಿಂಗ್ ದಟ್ ಟೈಮ್ ಟೆಂಪ್ರೇಚರ್ ಆ್ಯಂಡ್ ಪ್ರೆಷರ್ಸ್ ಆರ್ ಡೈರೆಕ್ಟ್ಲಿ ರಿಲೇಟೆಡ್. ಸೊ ಅವಾಗ ಏನಾಗ್ತಾ ಇದೆ, ಟೆಂಪ್ರೇಚರ್ ಮತ್ತು ಪ್ರೆಷರು ಡೈರೆಕ್ಟ್ಲಿ ರಿಲೇಟೆಡ್ ಇದೆ. ಸೊ ಅದನ್ನು ಇಲ್ಲಿ ಎಕ್ಸ್ಪ್ಲನೇಷನನ್ನು ಕೊಡ್ತಾನೆ, ಗೇ-ಯುಲಸೆಕ್. Okay, let us discuss about the Gay-Lussac law. He found the relation between the pressure and temperature during the hot air balloon experiment. Okay, how they are related? They are directly related. Therefore, the statement of Gay-Lussac law become at a constant temperature. At a constant volume. A constant volume. Pressure of a given mass of a gas. Pressure of a given mass of a gas varies directly with absolute temperature. Absolute temperature. ಸಾಪೇಕ್ಷಿತ ಉಷ್ಣತೆ ಅಂತ ಹೇಳ್ತೇವಲ್ವ ಕನ್ನಡದಲ್ಲಿ. Here, at constant volume, pressure of a given mass of a gas varies directly with absolute temperature. In another word, at a constant volume, pressure is directly proportional to absolute temperature. It is also correct. Okay, pressure is directly proportional to temperature, absolute temperature. Now, how to represent the law in terms of a mathematical form? In mathematical form, volume is constant, pressure of a given mass of a gas directly varies with the temperature at constant volume. Correct? So when we consider the proportionality constant, to remove this proportionality and consider the proportionality constant K, here I consider K3 because it is a third law. Okay, K3 is the proportionality constant K3 into P, where K3 is proportionality constant. Okay. Now I am changing or rearrange the equation. P by T, consider when rearrange the T, it becomes P by T is equal to K3. What is K3? K3 is constant, proportionality constant. Therefore, in another word, P by T is equal to constant. P by T is equal to constant. This is the mathematical form of Gay-Lussac law. Okay, so this is the mathematical form. Suppose we consider two or more system, then what happens? If we consider two or more system, the same equation is get converted into another form. If we consider two system, in case of the first system, the pressure is P1 and temperature is T1, and in another case, two system. In another system, P2, T2, the equation become P1 by T1 is equal to P2 by T2. Okay, P1 by T1 is equal to P2 by T2. This equation is required to solve the problems based on Gay-Lussac law. Okay, there is a possibility of asking the questions or problems on all these laws. To solve the problems, we need two or more system equations. Next, we move on to the another law. Before that, what is the graphical representation of Gay-Lussac law? The graphical representation is for P versus T. Okay, when we plot a graph of pressure versus temperature, here I am consider pressure along y-axis, temperature along x-axis. When change the volume for a different volume cases, we get straight curves. What we observe in case of Charles law, similar curves is observed because both are directly related, correct? So both are directly related. Gradual increase of the temperature, gradual increase of pressure take place in the system. Because of that, for a constant volume, for volume V1, V2, when increases the volume, then the curve goes upper side. Okay, the lower pressure volume, higher volume. Here what we obtain a constant volume curves, correct? ಇಲ್ಲಿ obtain ಮಾಡಿದ್ದೇವೆ ನಾವು ಕಾನ್ಸ್ಟೆಂಟ್ ವಾಲ್ಯೂಮ್ ಕರ್ವ್ಸ್ಗಳನ್ನು obtain ಮಾಡಿದ್ದೇವೆ. ಸೊ ಫಸ್ಟ್ ಕೇಸಲ್ಲಿ ಬಾಯ್ಸ್ ಲಾದಲ್ಲಿ ಏನು ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ದೇವೆ, ಬಾಯ್ಸ್ ಲಾದಲ್ಲಿ ಕಾನ್ಸ್ಟೆಂಟ್ ಟೆಂಪರೇಚರ್ ಕರ್ವ್ಸ್ ಐಸೋಥರ್ಮ್ಸ್. ಇಲ್ಲೇನು ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ದೇವೆ ಚಾರ್ಲ್ಸ್ ಲಾದಲ್ಲಿ, so in that cases constant pressure curve iso bars. Here iso cores, these are called iso cores. Isocore, isocore means, then what is the definition of isocore? Isocores are the constant volume curves obtained in pt graph. Is that P versus T graph, correct? So isocores are the constant volume curves obtained in PT graph. Okay, so this is the definition of isocore. This is about the Gay-Lussac law. According to your syllabus and the history of your question paper, when you observe the history of the question paper, Gay-Lussac law is not much important. Okay, these two are the very important laws, Boyles law and Charles law. The extended part of Charles law becomes the Gay-Lussac law. Okay, so ಏನಾಗಿದೆ ಇಲ್ಲಿ ಎಕ್ಸ್ಟೆಂಡೆಡ್ ಚಾರ್ಲ್ಸ್ ಲಾವನ್ನು ಸ್ಟಡಿ ಮಾಡ್ತಾ ಇರುವಾಗ ಏನು ಸ್ಟಡಿ ಮಾಡಿದ್ದಾನೆ ಅವನ ಜೊತೆಗೆ Gay-Lussac ಮಾಡಿರೋದ್ರಿಂದ ಸೇಮನ್ನು ಡಿವೈಡ್ ಮಾಡ್ಕೊಂಡಿದ್ದಾರೆ. ಸೇಮ್ ಒಂದು ಅಬ್ಸರ್ವೇಷನನ್ನು ಡಿವೈಡ್ ಮಾಡಿಕೊಂಡು ಎರಡು ಲಾ ಆಗಿ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ದಾರೆ. ಓಕೆ, next we move on to the fourth one, Avabhrata's law. So Avabhrata's law, you are already well known the Avabhrata's law during the study of some basic concept of chemistry, correct? So during the study of some basic concept of chemistry, we studied the Avabhrata's law. This P versus T. Now Avabhrata's law, what it gives. According to the Avabhrata's, or it states that at a constant volume, Avabhrata's law, given a mass of a gas, correct? So the given a mass of a gas varies with the volume. Okay, so what it states that ಎಷ್ಟು ಅಮೌಂಟ್ ಆಫ್ ಗ್ಯಾಸ್ ಇದೆ ಆ ಗ್ಯಾಸು ವಾಲ್ಯೂಮ್ ಜೊತೆಗೆ ವೇರಿಯೇಷನ್ ಇದೆ, ಡೈರೆಕ್ಟ್ಲಿ ವೇರೀಸ್. ಯಾವಾಗ? ವೆನ್ it varies directly when all the conditions are, all other conditions are constant. Other conditions are temperature and pressure. Okay, when constant condition of temperature and pressure is there, at that condition volume of a gas is varies directly with the amount of the gas. The same thing we were discussed in the some basic concept of chemistry topic. In that case, same statement is also used here as Avabhrata's law. At a constant temperature and pressure, the equal volume of all gases contains same number of gaseous molecule. Equal volume of all gases at a given condition of temperature and pressure contains same number of molecule. There is no confusion. Okay, ಅಲ್ಲೇನು ಕನ್ಫ್ಯೂಷನ್ ಮಾಡ್ಕೋಬೇಡಿ, ಕನ್ಫ್ಯೂಷನ್ ಕೂಡ ಇಲ್ಲ. ಓಕೆ. ಸೊ ಅದನ್ನು ಎರಡು ರೀತಿಯಾಗಿ ನಾವು ಎಕ್ಸ್ಪ್ಲನೇಷನನ್ನು ಕೊಡ್ಬೋದು. ಓಕೆ, ಬಟ್ ನೀವು ಏನು ಕಲ್ತಿದ್ರಿ, ಸೊ ಫಸ್ಟ್ ಟಾಪಿಕ್ನಲ್ಲಿ ಸೇಮ್ ಸ್ಟೇಟ್ಮೆಂಟನ್ನು ಇಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ಬೋದು. ಓಕೆ, ವಾಟ್ ಇಟ್ ಸ್ಟೇಟ್, ಇಟ್ಸ್ ಅವಗೇಡ್ರೋಸ್ ಲಾ ಸ್ಟೇಟ್ಸ್ ದ್ಯಾಟ್ equal, it states that equal volume of all gas at a constant temperature and pressure or given a condition. Okay. It is also called in terms of given a condition. Equal volume of all gases at a constant temperature and pressure contains same number of gaseous molecules. So this is the statement of Avabhrata's law. Let us discuss about the mathematical form, the Avabhrata's law. What happened in case of this volume varies with gaseous molecule? When we increase the number of gaseous molecule, what happened the mass of the system? When we increase this number of molecule, mass of the system is increases, or amount of substance is increases, correct? So amount of the substance, this gaseous molecule, number of gaseous molecule is nothing but amount of a substance. Amount of substance is explained in terms of a mole. Therefore the mathematical form of Avogadro's law, understand the concept? Okay, number of gaseous molecule, number of particle is directly related to moles, or it is measured in terms of moles, because gaseous molecules are very smaller things are explained in terms of a mole. So therefore volume is directly related to the amount of the substance, This is the mathematical form of Avogadro's law. Now I'm replace the proportionality constant by using the constant factor, again k4. Why I am considering k4? It is a fourth law, therefore it is k4n. Again I am rearrange the things. V by n is equal to k4, V by n is equal to constant, it is for one system. This is the mathematical form of Avogadro's law. Now I am changed into two systems. Suppose the two system contains volume V1 V2 and amount of a gases or number of gases molecules N1 and N2. Now the equation become V1 by N1 equal to V2 by N2. So this is the Avogadro's mathematical form of Avogadro's law. Okay, now in this case what we obtain, V is equal to k4n. Here I am consider it is equation number 1. We already know that another concept or another thing, that is n is a amount of a substance, it's a mole. But the mole is also expressed in terms of the mass. How to express or how to give the relation between mole and mass? Mass in a gram divided by molar mass gives the number of moles, correct? So we know that n is equal to m by m, equation number 2. Okay, we know that. Just extend the Avogadro's law to this case or density cases. Okay, what happened? We know that mole is equal to mass in a gram. Mass in a gram become here gaseous molecule, therefore given a mass of a gas divided by molar mass of that gas gives the mole. substitute substitute equation number 2 substitute equation number 2 in 1. We get what we get, V is equal to K4 M divided by M. I am rearrange the equation. It is equation number 3. Suppose it is considered 3. Rearrange the equation 3. We get V comes here and M goes here. Molar mass of a substance is equal to K4 M by V. What is the meaning of M by V? Mass in a gram divided by volume. Mass divided by volume is nothing but density. Okay. But M by V is equal to density. Therefore, equation number 4 becomes ಏನಾಗ್ತದೆ equation number 4 M is equal to K4 D. What is K4? K4 is proportionality constant. What is D? Density. Suppose we remove the proportionality constant. What happens when we remove the proportionality constant? We get proportionality. Correct? When you remove the proportionality constant, it becomes proportionality. Now I am remove the proportionality constant. It becomes M is directly proportional to D. What it gives? M is directly proportional to V. K4, I remove the K4. Okay. Now M is directly proportional to D. What is the meaning of M is directly proportional to D? Molar mass of a gas. When molar mass of a gas is increases, then density increases. Correct? Or density increases directly with the molar mass of a gas. ಅಲ್ವಾ? ದಪ್ಪ ಇದೆ, ವಜ್ಜೆ ಇದೆ, ತೂಕ ಇದೆ ಅಂದರೆ ಅದು ಡೆನ್ಸಿಟಿನೂ ಜಾಸ್ತಿ ಇರುತ್ತೆ. ಡೆನ್ಸಿಟಿ ಜಾಸ್ತಿ ಆಗಿದೆ ಅಂದರೆ ಮೊಲಾರ್ ಮಾಸ್ ಜಾಸ್ತಿ ಇದೆ. ಅದನ್ನು ಅವಗಡ್ರೋಸ್ ಲಾದಿಂದ ಪ್ರೂವ್ ಮಾಡಿ. ಓಕೆ, ಸೊ ದಿಸ್ ಇಸ್ ದ ಜಸ್ಟ್ ಎಕ್ಸ್ಟೆಂಡೆಡ್ ಪಾರ್ಟ್ ಆಫ್ ದಿಸ್. Okay, there is a possibility of asking the question on this case also. Give the relation between molar mass and density using Avabhra's law. It is nothing but relation between molar mass and density. Okay, is relation between molar mass and density using Avabhra's law. Okay, we give the another relation using Boyles law also. Correct? So using Boyles law, we give the relation between pressure and density. Here, molar mass and density. Okay. After study of all this law, there is another things or another concept comes into the syllabus. That is combination of these three important laws that gives the different concept and different idea. That part will be discussed in the next video. Thank you for watching.